Okay, determine the domain of functions. First question wants to know the domain of function h here. Well, the big thing here is when you're dealing with domains, you're looking at what x's can and can't be put in. And in this particular one, when I look at this, I see a fraction. And there's only one situation really that jumps out as fractions. The denominator of a fraction cannot be 0. So what I'm really saying here is when I want to talk about my domain here is x minus 5 cannot be 0. Now, if I solve this just like any other equation, I add 5 to both sides. The one thing I get is that x cannot be 5. It can be anything other than 5. If you put in a number bigger than 5, fine. If you put in another smaller than 5, fine. But the one thing that cannot happen is x cannot be 5. So it's everything but x is 5. All right, next one. Now, this is a little different. And this one's a little different because it's dealing with square roots. Well, you can take the square root of basically any number that's 0 or larger. So what's going on here is x plus 3 must be greater than or equal to 0. Okay, it has to be bigger than or equal to 0. If you put in a number that makes this negative, you can't take the square root of a negative. Not in the real world. You can in imaginary numbers, but we're not talking about those right now. So we need this to be bigger than 0. So again, all you're doing is adding negative 3 to both sides. And you're saying x has to be greater than or equal to negative 3 in order to make this not be less than 0. So my answer is right here. My answer is going to be B. All right, next one. What is the domain? Now, here's the thing. When I look at this one, there's nothing unusual going on. There's no square roots. There's no fractions. There's no powers. There's nothing unusual going on here. And what that tells me is there's not going to be any limitations to the domain. You can put anything. You can subtract 4 from anything. There's no reason you can't subtract 4 from a number. So here it's all real values. And again, if you think about the previous two, you had the one that had the fraction, that created an issue. You had the one that had a square root, that created an issue. This doesn't have any of that stuff. So the domain is going to be very straightforward here. Last one, we're back to fractions again. Now again, the big thing with fractions, and we're going to copy this one, the big thing to understand about fractions is you don't care if the top is 0. The top of a fraction can be 0. 0 divided by any number is 0. It doesn't matter. That's okay. You can take 0 divided by 11. That's 0. But 11 divided by 0 is undefined. It doesn't exist. There is nothing, because the question you're really asking is, this question is, what number times 11 is 0? Well, 11 times 0 is 0. This question is, what number times 0 is 11? That doesn't exist. So I'm not really worried about the x on the top. It doesn't really affect anything. So again, just like the question 1, what we're really wanting is this cannot be 0. So if you add 7, you get x cannot be 7. X cannot be 7. I think that one's pretty straightforward. Again, maybe there's something that's more complex than I think. Ask a question if you don't understand something.